There are times in our lives when we get sort of blindsided by these very deep, very terrifying existential questions. And even if you're not a parent, you might be familiar with this one. Dad, what do you do? And just as you're wrestling with that particular difficulty, it's usually followed up by this one. Why? Well, Jake and I are automation software developers in tests, but I can tell you that's just not going to cut it with a 4-year-old. Now, fortunately, greater minds than mine have set themselves to this task, starting with the late, great Douglas Adams, who was apparently rarely happier than when he was spending an entire day programming his computer to perform automatically a task that would otherwise take him a good 10 seconds to do by hand. I mean, that's incredible, a day. I know this was pre-agile, but sometimes it takes Jake and I weeks. You try pairing 2 Bluetooth devices together reliably. And it's true. We spend an awful lot of our time writing code that does things that our users would normally do by hand, and a lot quicker. And then that can be a lot of fun watching the unit sort of apparently perform tasks under your control. But as to the why, that's a little trickier, and I've had to go further back in time to 1982, the swords and sorcery epic Conan the Barbarian. And Conan is asked, what is the best in life? Now, 40 years is a long time, and attitudes and times change. And looking at some of you, I'm aware that some of you probably weren't even born when this was gracing our screens, so I'm paraphrasing a little. But the best in life, well, clearly, is to crush your enemy's binaries, see their stack dumps driven before you, and to hear the lamentation of their compilers. Because after Jake and I have spent our days and weeks honing our code, we unleash it on other people's code, their firmware, their hardware, in a way that makes robot wars seem like Sunday afternoon tea. And we do this not because we are mean and malicious, or we want to crush our developers' hopes and aspirations. I mean, some of them are in the audience, they may disagree with that. But anyway, we know that when we give our devices to the users, they place great demands on them, perhaps unreasonable demands. And it only takes one single sample drop, 192,000th of a second, to have a take go south very, very quickly. And we can't have that. And as someone who used to run a studio, I can tell you, you don't want to be the person telling that group of musicians who are now enjoying the relaxation of their choice, they've got to go back into the live room because you've had a blue screen or driver crash or the audio is glitchy. So if it means some tough love on our developers and our units, so be it. So, in the words of Mr. David Byrne, how did I get here? We've had the what and the why. Well, I joined Focusrite about 5 years ago to work on a greenfield project to automate the driver, firmware, and feature testing of what was then the Scarlett Gen 3 range. So why was Focusrite desiring to invest in automation? Well, let's pick one test. This is the round-trip latency of a Gen 3 Scarlett 8920. We've got a cable coming from the outputs back into the inputs, and we send a signal out, and we measure how long it takes to get out and back in again. On the Z-axis, we've got all the buffer sizes we support, and you'll notice we support many more than the standard 7. On the X-axis, which you can't actually see, but it's down here, we've got the 6 standard sample rates, and that gives us the round-trip latency. And hopefully, as you might expect, there's a linear relationship between the two. If I double the buffer size, the round-trip latency should roughly double, and if I double the sample rate, then the round-trip latency should halve. And I think you can it's pretty much as you would expect. So, first t-shirt is up for grabs. If I said to you, you could measure one of these combinations at an average of once per minute. Anyone want to hazard a guess as to how long that would take you to do? 6 sample rates, 64 buffer sizes. Anyone? Anyone from Focusrite? 1 day. Thank you very much, sir. You can have a t-shirt. Yes, that would take you 384 minutes. Let's call it 6.5 hours. We might even give you an hour for lunch. So that's going to take you a whole day to do just that chart. But of course, there's a problem, because there were 6 units in that range. And we needed to test on Windows 7 at the time, both flavors, Windows 8, where you can see where this is going, Windows 10, and 2 versions of Mac. So we've got a bigger problem. Let's be generous. Let's now say we've got 3 testers of the problem, still at 1 per minute, and we're going to make them work in 8-hour shifts, but no lunch break, so they're going to be working straight 24 hours. Anyone want to hazard a guess as to how long that is going to take you? To the nearest day. Wow, tough crowd. All right, it's going to take you 384 units, 6 units, 8 OSs, 18,432 measurements, 13 days. You're not going to be sane at the end of it, but that's how long it's going to take you. But of course, there is a problem, because we wanted to do comparisons with the Gen 2 range, with the Claret, Thunderbolt, and USB versions. Claret Plus, Red, Vocaster, for every firmware release, every driver release. If we were on Windows 64-bit, we want to do 32-bit and 64-bit clients, and ASIO and WDM, safe mode. So you can see it becomes a huge matrix and just physically impossible to do by hand. And many of our tests live in this matrix, so we want to run them on all these OSs, on all these buffer sizes. So how do we solve that problem? So this is my desk 4 years ago. And basically, I'd gathered any laptops that I could beg, borrow, or steal, stuck them on my desk, pile of units, got some Arduinos in there, and I've got Python running some code. And yes, there's a blue screen there. So this is what we came up with, and that was actually running some tests. But of course, there was a problem. It wasn't really fully automated. I had to sit there, go to every machine, start the tests, all the logs and stuff are on all the machines. It's quite laborious. And I had to basically read through the log files every day. We had lots of glitches. Tests would fail, not because the feature would fail, but because somewhere along the line, there was a glitch. And I spent a lot of time staring at sine waves in Audacity, trying to figure out the reasons for discontinuities. Very time-consuming. Blue screens. What seemed to happen is I would set the tests going, ready for an evening, and sometime between me leaving the building and getting in my car, there'd be a blue screen. And the following morning, I'd be hunting down symbol files and chanting WinDBG roots. Machine maintenance. As they say, you're only ever one Windows update away from being completely screwed. And many a time we were completely screwed. Installing, uninstalling drivers, very, very tedious. 2018, and I'm still calling out a sub-process to scrape text back from a console. Incredibly tedious. The tools were very, very primitive. And when you introduce automation to any project, you get that lots of, can you do that by hand? And I had to add like a speed control into the test rig to slow it down a bit. And spoilers, that didn't make any difference. So if you've been in software any length of time, you'll know that all paths will lead you to a database. And this is a snippet of our database. And that was to try and handle the recovery from blue screens. So what we did, we had the idea of a test suite, and the machines would pick up the test suite from the database. If there was one that they started running, they would look at the test, and once they got to that point and started testing division, we go, okay, let's not run that test again, let's move on to the next one. So that started us being able to recover from those blue screens. There's an expression, when the student is ready, the master shall appear. So we had all these other problems. And in this case, the master turned out to be someone who joined the company fairly recently, and one Friday afternoon, I was lamenting the problems with the sound libraries when Mr. Anthony Nichols, give us a wave, Anthony, came over and wisely, or perhaps foolishly, found himself saying these words, I can probably knock something together in Juice this weekend. And indeed, that was when the levels tool was born. And that basically opened doors for us to be able to do a bunch of testing that we just simply couldn't do before. It's kind of like going from second gear to fifth, all in one word. And then we hired an infrastructure engineer who basically came along and said, I will take all those machines off your desk, I will put them somewhere, I will handle the scheduling. You just go and write your tests. This is actually the tidier part of the lab, and there are some bits of it I can't actually show you because of what stuff we're working on. So yeah, sometime later, we've got a lab, and we've got a bunch of laptops, we've got a bunch of Macs, we've got a bunch of Windows machines, a whole bunch of units, all wired up neatly. I'd like to say that my desk is now a pinnacle of feng shui goodness, but actually I haven't basically any tidier. So that's the hardware side of things. And just as an aside, I came across this talk, Bobster Girl, it's on YouTube, well worth watching. And he basically says, the field is where you have minimal or no control of the context. Can't disagree with that. But then he says, the lab is a setting where you have total control of the context. And to that, I have to say, Bob, if you spend any time in our lab, you might choose to revisit this decision, because total control is more of an aspiration and actually largely more of an illusion. And I've got a little video later on which I recorded, and if you're quick enough, you can see where that total control isn't quite actually working. So, got the hardware sorted out, and then Mark, our infrastructure engineer, started writing a scheduler, which is known as the Focusrite Automation Test Controller, or the FAT controller for short. And basically, what it does is we can give it a file, binary file. That might be a driver, it might be a piece of firmware, and that might be me uploading it manually. It could come from our CI pipeline or part of our regular scheduled tasks. The scheduler knows about all the machines and all the units that's connected to them, and it basically starts a job card for those machines and assigns them to the various computers. All the tests get added to the database, and then when the computers are ready, and they're not doing anything, they'll be started and start running tests. If it's Windows, we deploy a golden image to those machines so we know where we're starting from. We get all the tools we're going to need, the latest version of the test harness, and then basically we beat the OS from an advertising platform into a proper OS. We make sure it's not going to do things like go virus scanning or download updates. We then run the tests. We've got a pre-flight to make sure the units can actually do stream audio at all. We might be recovering from a blue screen. And we've got the idea of fatal errors where we know the unit's completely hosed, or non-fatal errors where we can actually recover from that. Once the test is run, we get all of the files that have been generated as part of that test, stack dumps, WAV files, logs, plots. We copy them center each of the server. So this is a video I recorded earlier, and what I'm going to do is basically take our latest driver from our website and run it through some tests on 3 of our units. And I would say that the only editing that's been done on this is to basically reduce the length of time that it takes. I haven't actually done any editing to, I haven't changed or anything with Cheetah. And if you can watch the playback if you so desire. So I'm going to upload a file manually. And it's the latest driver, and I'm going to pick 3 units. And I'm going to do a Windows 10, a Windows 11, and a Mac for comparison. This is a sanity check on the driver, and you can't see, but I'm also going to say, hey, I would like an email when this job is finished. And then I'm going to go down and select some tests. We're going to do a quick, simple driver test. We're going to do a enumeration test, taking it on and off the bus. And because it's Windows, we're going to do some ASIO and WDM mixed up, because that's a great way of causing glitches. And then I'm going to start the test running. Quick edit. There's an error come up because somebody changed something in the lab without telling me. And we've got a past here, so we're going to go look at that one. We've got lots of information about all of the configuration, the environment it found itself in. We've got our pre-flight and our 3 tests. All the lights are green, no glitches, no errors, no blue screens. Fantastic, which is what we would expect for a release driver. If you're not familiar with the test, we can actually look and see what the tests are doing in these flowcharts that we've made to give sort of a high level of what the test is actually doing when it's run. If we did have any glitches, they'd be down here. Every audio clip that we played would basically have a plot by it. But because we haven't got any glitches, this is nice and clean, which is what we want. And that's a very, very quick overview of the FAT controller. It can do many, many more things. And at the end of its run, it will basically give me this list of output. You can see here some of the machines were not happy. Some of the machines will stop responding at all. Some of them don't support the test that we've got. And every day, Jake and I get like a daily digest of all the tests that were run the night before, and on the weekends, there's more extensive tests run. So what is it made from? We're currently using Python 3.9, moving to Python 3.10. We're not concerned about the speed of Python. We play thousands of clips all the time. What is important to us is making sure it's cross-platform, so we've only got one code base to support. The same with our tools, C++ Juice, so we basically have one code base. We can run that on Mac, we can run that on Windows. FAT controller itself, PHP, we use Fog to deploy images, JavaScript for the front end, and we've also got no machine running on the machine, so we can remote into them. We also have some custom hardware, little boards that sit on the USB bus, so we can mimic connecting and disconnecting cables, we can measure the voltage and power over time, how the devices are actually performing. And that's MicroPython and CircuitPython. Test harness is probably about 25,000, 30,000 lines of code. It goes up and down, and the FAT controller is about the same. As to how much work it actually does per week, and this is a very crude measurement, we basically look at how long it would take a human person to run all these commands, and it's about 4.5 person years per week. There are variances, as some drivers don't last very long under the onslaught of testing. We have people doing private builds, submitting builds, and if we have a driver release, there's usually a peak of testing. So it does an awful lot. So these are some hard-won, thoughts that many years of experience have taught me. And if there's just one thing you remember from this talk, it would be this. If it isn't tested, it's broken. Can you imagine if Irwin's cat said, so my choices are coming out of the box, dying, or being trapped in some sort of quantum entanglement that isn't going to be released from until this wave function gets collapsed. No. If it isn't tested, we assume it's broken. Those of you who test-driven development will be familiar with this one. Didn't fail. We write the test. Mr. Karl Popper. Falsification will prove it. I've seen so many tests where basically, here's the heat death of the universe, and here's the probability of the test failing. There are so many things that would have to go wrong before that test would actually fail. This is an interesting one. We have to write better code than the code we're actually testing. We can't run a 24-hour stress test if our code packs up after an hour. Single oracles. If I have an API and I say, hey, set the gain on channel 1 to 10 dB, and ask that same API, hey, what's the channel 1 gain? And it says 10 dB. Do I believe it? Some of you might be familiar with the 3 Mile Island nuclear disaster, and one of the main contributors to that was there was a control panel for the pressure release valve, and on that control panel was a green light. And the operator reasonably assumed that the control panel controlling the water was in fact closed. And what the control panel actually meant was, yeah, I've received your request to close that valve. I haven't actually done it. Meanwhile, the containment building is flooding. So trust but verify. Bit contentious, this one. I can guarantee you, if your project is running late, adding automated testing to it is going to make it later, because we are going to find things that you haven't thought of yet. And many of the bugs we find are actually when we're actually writing the test and then running for the first time. Okay, huge foreshadowing. There's another t-shirt coming up if anybody wants to jump in. So, this is a safe place, right? We're all a bunch of developers here, so I'm going to go out there on a limb, and maybe it's just me. But coding's really hard. I mean, really, really hard. And I'm not a great programmer. I write procedural code, and I enjoy it. You hear about these 10x programmers. I'm probably more in the sort of 1/x. And that's okay, because I can go on Stack Overflow and see that I'm not alone. And in fact, the way I look at it, statistically, the average quality of my code is actually going up over time. Well, that presents somewhat of a paradox, because I said, we have to write better code than the code we're testing. And if I could write better code than the developers, wouldn't it make sense for me to write that code in the first place? And then we end this regression loop of who actually writes the code and who writes the tests. So how do we solve that problem? So how to think about this? And in the spirit of reusing other people's material, I'm going to recycle an old dad joke. 2 developers decide to go for a hiking weekend in the beautiful Montana countryside. They've been walking through the woods for a while, and they come across a clearing. Beautiful. Unfortunately, in that clearing, they've disturbed a rather large, rather angry, but most importantly, very hungry bear. One of those developers, who might be wearing a Conan t-shirt, immediately throws down his backpack and starts sprinting back towards the tree line. The remaining developer is perplexed. He stares at the backpack. He stares at the charging bear, and he stares at his colleague disappearing into the tree line. And he shouts out, "Are you mad? You can't outrun a bear." To which the voice on the tree line replies, "Anyway." I've only got 1 t-shirt, so you're going to have to fight over that. Yes. I can't write better code than the code I'm testing, but I will use every trick in the book to make sure I'm just going to last that tiny bit longer than you can. And believe me, I've been walking in the woods a fair amount of time, and I know where the bears are. So, without further ado, fresh back from a weekend in the wilderness with a party that came back suspiciously smaller than he went out with, I'm going to hand you over to Jake.
Thanks, Joe. So Joe's spoken about our humble beginnings and sort of the challenges we faced right at the start. That was 5 years ago. I'm going to talk about where we are now and where we want to go. So first things first, we're a bigger team. So it was just Joe at his desk, like we saw, load of laptops that he managed to get. We're now a team of 3 full-time developers. So myself, I joined the team 2-3 years ago, and we've just had a new member team start like last week. So 3 full-time developers just working on test automation. We also have Mark, who we've previously mentioned, in infrastructure, who, full-time doing our infrastructure, making sure that all our tests can run on the right hardware and the right conditions in the lab. We also have a full-time tools developer in the company. He's not just serving automation, there are other parts of the business he serves, but he gives them and puts them in a much better place. So shout out to James Hallowell over there. So bigger team, more tests being written, more flying hours. So that's how we kind of measure what the automation is doing. How many hours are we running the tests for? And how much confidence does that give us in the device? Because a lot of the problems we have are timing issues. Like if you have a driver or some firmware that's doing some processing, it's probably going to work most of the time, but then sometimes it doesn't for whatever reason. And that's what we're trying to find and get down. So with that, we found the sort of the source of a lot of our problems. So our blue screens are down. There used to be a lot of problems with blue screens for the driver. It's very rare to see an issue now. And our glitches are down, so we've fixed a lot of the glitches we had in the firmware or in the driver too. We've become an integral part of product development. So we recently released Focaster in May or June this year, and it was automated from the very start, and it shipped with over 1 million clips played and around 2 years of test time. So that's 2 times 365 times 2, 364 times 2 times 24. So there's a lot of hours on that product, and we released with big level of confidence. We've become part of the CI pipeline, which has made us much closer with the firmware team, so they can write their code, push a build up to CI. That will dump the firmware build onto our artifact repository, and then we can just pull that down onto the test rig and run it. We can get a very quick feedback loop, and we can make sure that no manual QA is wasted on firmware that isn't quite ready for it. Automation then, that means we're a customer now. So things that break the rig get fixed. So we can't have tests fail. We don't just allow that. We have to find the cause because it's trusted, and we feel we can't really release a product without going for automation now. To think we didn't have this 5 years ago, and now we're so in that loop, we've come a long way. And some of the issues that Joe spoke about, staring at WAVs in Audacity to try and find a particular glitch, or chanting WinDBG runes to understand why a blue screen happened, those problems have been solved. But we still have some challenges. So this is one we play a lot. Whose glitch is it anyway? So if you think about the system, we're testing end-to-end, but really end-to-end. In the system, there's the driver for on Windows. There's the firmware running on the device itself. There's the communication software that we're using to talk to the firmware remotely from the computer. There's our code, which has to work too. And there's the OS itself, and it does, of course. And the OS itself. And if for a test to pass, all those have to work properly. For a test to fail, one of those just has to give up somewhere. We don't know necessarily where it is. So enter, here's a glitch. So this glitch is quite a simple one. You can see it's almost like there's just a small delay and it fixes itself. I don't know what the root cause of that would be. I could take a guess, but I don't know. It could be the firmware, it could be the driver, it could be the OS. It wouldn't be us in that case, so we're off the hook. But I don't know. And how we record this is that we've got the device, the audio output is looped back to the audio input, playing out a sine. Sign comes back in, we're not throwing out the sign, and anything left over is we flag as a glitch, and we can automatically see it's a glitch and then look at the file, and you can see the problem quite simply. But it doesn't tell me where the problem is. Enter this guy. So if you might have heard of Beagle USB analyzers. We have one of those now on the system too. So what that means is we can see what we sent out. So this is what the firmware actually received over USB. So we can see it's a clean sign. There's no problem there. So already we can rule out the generation of the audio we use in our tool and the transfer across the driver to the device. This is what the firmware sent back out, so we can see it's going out over the USB cable. And again, that's fine. So we can rule out the firmware because it's done all the processing. It's gone through the ADCs and the DACs in that analog loopback. The cables are all fine because there's no glitch there. But then we see the end result again. So it's going to be somewhere in the OS or the driver coming back in on the record side. So that really helps us understand the problem. So this is just an example of how we're trying to get what we want to test end to end, because we're trying to use this as we're trying to mimic the user And we can't isolate these things too much. And this isn't the only testing we have in the company. Obviously, there's unit tests at a firmware level and other types of testing, manual QA. But we want to try and automate that whole system. And we're trying to find ways to constantly increase the level of information we can provide back. So we can provide these audio files and USB logs and all sorts of information that can try and prove exactly where the problem is. But it is still a complicated thing, and it's a constant battle. So the road ahead. Where are we going to go now? We've been going for 5 years. We need to work out, what's next. Well, as I said, we've got a full-time tool developer, and while we already have that, the reason I mention it is because Joe said about how when he started, he had to deal with all old tools that weren't really developed for automation and lots of sub-processing and scraping text back. And we're now at a place where we have someone in the company that can provide us what we need, and that's really powerful and really help our testing out and gives a lot more finer control. Automated glitch classification. So I saw that glitch. Just one example of ones we see. We have some crude Python algorithms to try and work out what type of glitch you have and sort of classify it so we can build data on that. But I think we're at the point where we want to go better. So we've got someone looking into sort of some machine learning we can do on that. Because it is just a classification problem most of the time. And we want to build the stat sock. Because then we don't want to just say we have this driver version and we can do this through Fat Controller. We can see of all the tests we've done on this driver version, how many glitches does it have? We don't necessarily just want to say, it had X glitches. We'd like to know what types of glitches, because different types of glitches would maybe infer different root causes. We want to make sure we fix each one of them and not just one of them. So we want to expand and extend wider test authors, users. So we've expanded it a lot. What started off as a Gen 3 rig it now supports Red, Claret, Vocaster, even some Novation devices we're starting to work with as well. We want to push into Novation more, but as well we want to get more people writing tests for the rig. So quite recently we've been working closely with the firmware team. That's really exciting, the idea that they can be writing tests in our system. Because it is, we've tried to build a framework. It's difficult, there's no off-the-shelf solution we could use, but we're hoping that what we have now people can contribute to more, and we can just grow more and more automation. And users, I mean, QA are the primary users of automation, kind of obviously, but more and more people understand how to use that system and how to interpret the data, because we get a lot of data back, and that's another place where we need to look into, what can we do with that data, because sometimes it can be difficult. And finally, Joe touched upon this, but we have some early hardware automation. So far, every test is using some sort of software communication to control the device. So same way our control software works. So if you're familiar with Focusrite Control or Vocaster Hub, for example, we're using the same sort of protocol in the back end, which is fine. The user will use that route, but also the user will press buttons on the front panel and physically pull the USB cable out at some point, and that's something we need to test for as well. So we've started to develop some of those boards, and I think we want to push forward in that direction as well and really try and test the full system as close as a user would. And that's it for me. I'm going to pass back to you now. Sure.
So we have.
Sorry.
So who's been paying attention? Up for grabs. Here's an Arnie T-shirt. Yours, if you can answer, what is best in life? Right, okay. If it's not tested, it's... who said that? Sir, you can have this, because I'm not carrying it home again. Thank you very much. So, I suppose we should allow you to ask us some questions, if you so desire.
Hello, thank you. Right, great talk. It's good to see you've made so much progress in kind of a relatively short time, it seems. I was wondering if you could kind of touch on, so you're talking about this comparison to reference sine waves and stuff, so kind of a golden file approach. How do you deal with, say, physical differences in the preamps and stuff? Like, is there a tolerance? How do you detect the glitches?
So,
things like that.
So how do we detect glitches and deal with difference in tolerances? So we have, when we get units, we've got a rough idea of where the gains should be. When we feed it a certain signal, we expect a signal back. And because we're not sort of doing production line testing, we do have a tolerance. This lady came for an interview and she introduced me to the math.isClose function in Python. And basically we allow plus or minus, say, 1 dB, depending on what the test is, because there's always going to be some variance in that. So we're looking for sort of like big differences, if you like. So, and that's generally what happens. If we get a glitch, there's usually quite a big difference in the level. So we've got an idea of, we use the levels tool and we say, hey, I send out this signal, this is what I'm expecting, more or less, plus a little bit. So there is a certain amount of looseness, and over time we've been able to basically tighten that up. There are still things, we get noise in the system, but largely we've got our units are like described in a file format, so we can say, hey, this unit should have this amount for this output, and it's always looped back in. We always cross over the cables, so we have reasonable control over that.
Okay, thank you. And like a follow-on from that would be, I guess it's easier when you're dealing with like a system that outputs and a system that inputs, and it's kind of mainly gain that it's changing there. But with a system that performed DSP, where you're not getting a sine wave back, do you have any kind of thoughts on testing the output there, and how would you analyze it and establish like a state that's okay to then reference in future tests for regression?
So basically the question is, how do we deal with DSP when we don't have a sound wave? Jake, do you want to take this one? Because Vocaster had DSP on it.
Yeah, sure. So on Vocaster, if you're not aware, there's a compressor and an equalizer that runs on the firmware. And the way we dealt with that was we still use some sign testing for stress testing, because they will have an effect on it, but we should still be able to know if it glitches or not during that, because we can just work out where the noise floor should be and sort of set it there. In terms of, we still want to test with real program material as well, so we have what we call golden references, so we know what it should sound. We have a product approved kind of algorithm, and this is what it should sound like, so we just feed some voice. For Vocast, we use voice because it was a streaming podcaster product, but it could be anything. And then we kind of take we save that as a golden reference, and then we just do time aligning and then phase something to make sure the new firmware under test is the same. And that would also pick up glitches as long as we were confident the golden image didn't have a glitch in it as well. So that's kind of how we use it on non-signs. Cheers.
Yeah, I think we're going to wrap it up. I don't know about you, but next time we need to test iLox, I know who to call.
You can come grab us at the bar later, Rose.
Yeah.
Yeah.
Thank you.
Thank you very much.